Welcome, everyone. Today, we're going to explore the process of analyzing a truss, starting with finding its slope. On this first slide, titled Step 1, Finding the Slope of Truss, we'll look at how TANA is involved. We'll also see how to determine the live load on the roof truss. This presentation will guide you through each step in detail, so let's get started and dive into the fundamentals of truss analysis. Let's consider the properties of the truss we're working with. The roof has a sloping design with an angle of 30 degrees, which is quite typical for such structures. Access to the roof is restricted, except for maintenance purposes, so safety and accessibility are important factors in our design considerations. Now, moving on to the load specifications as per the code. The code specifies that the uniformly distributed imposed load, which is measured on the plane area of the roof, varies depending on the type of roof surface. For flat, sloping, or curved roofs with slopes up to and including 10 degrees, the imposed load is taken as 0.75 kilonewtons per square meter. This value is based on the standards outlined in IS 875 Part 2 from 1987, specifically in Clause 4.1 and Table 2. It's crucial to apply this uniform load accurately in our structural calculations to ensure safety and compliance with the code. Understanding these properties and code requirements helps us design a roof that is both resilient and compliant, especially considering the 30-degree slope we're working with. All right, so in this slide, we're looking at a situation where our slope is greater than 10 degrees. Specifically, it's 30 degrees. According to Clause 4.1, there's a specific way to adjust the live load for roof membrane sheets or purlins based on the slope. What this means is that for slopes over 10 degrees, we need to subtract 0.02 kilonewtons per square meter for each degree above 10 from the base value of 0.75 kilonewtons per square meter. So the total live load is calculated as 0.75 minus 0.02 times the difference between our slope and 10 degrees. Plugging in our numbers, that's 0.75 minus 0.02 times 30 minus 10, which simplifies to 0.75 minus 0.02 times 20. That calculation gives us a total live load of 0.35 kilonewtons per square meter. The key takeaway here is how the slope affects the live load values, and this formula helps us adjust the load accordingly to ensure our design remains safe and efficient. This adjustment is crucial as it helps us account for the increased slope, which can influence the structural requirements of the roof.